Okay, so for our multiplying rational numbers, just like any other lesson, I would start with our prior knowledge. And so for our prior knowledge, I would talk again about adding and subtracting rational numbers and recalling what we would have to do to finish those operations. Also about multiplying side numbers. So a positive and a positive will always multiply together to get you a positive. A negative will multiply by a negative to get a positive. And then if we have one positive and one negative, it will give us a negative number. So then I'll jump right in and we'll start with the identity property. And what I did here is, after seeing other videos, I would then put the additive identity in first and review that with the students, and then go right into the multiplicative identity, and so the students can see how they're related. So we would start with our additive identity, and we would recall that our additive identity was 0, and that anytime we added 0 to a number, we did not change that number at all. So when we thought, what plus 9 will keep it the answer 9, and we know that's 0, anything plus 0 will remain the same. And so that works the same with negative numbers. And we had negative 17, we could add 0, and because 0 is the identity, nothing changed for our answer. Now the multiplicative identity is 1. So anything times 1 will always remain itself. So I know if I multiply 9 by 1, I'll get 9. And so something times negative 17 still gives me negative 17, so we know we must have multiplied by the identity, or 1. Same thing works for the number 0. I multiply something by 0 and get 0, so I know it must have been the identity, so we multiplied by 1. So, as we remember, the additive identity is 0, but the multiplicative identity is 1. This would then lead into the existence of inverses. Additive inverses make 0 pairs, or make 0. This we learned in a few lessons ago, and so we would use this as a review. And we would remember that anything plus its inverse gives us 0. Well, inverse, we know, are the opposites. So instead of positive 7, our opposite would be negative 7. And we know adding the opposite gives us 0. So if we think I have negative 4/9, I have to add that to something and create a 0 pair. So I'm going to use my inverse, or our opposite, and if it's a negative here, ours will have to be positive, and it's going to stay the same number, so I'm going to add 4/9. And because these are inverses, then we know they are going to be 0. Now we're going to take this and lead into the multiplicative inverse, where we know multiplicative inverses make 1. And so what we'll do here is we're actually going to use something called a reciprocal, which is where we take a fraction and we flip that fraction. The numerator becomes the denominator, and the denominator becomes the numerator. So I need to have something times 1/7 that'll equal 1. Well, the reciprocal would be 7/1. So multiplying by the reciprocal will make 1. Just like before, when I added the opposite, I made 0, got back to our identity. Here, same thing, we're going to multiply by the inverse, or the reciprocal, and equal 1. So we know here, if I have negative 4/9, and I need to multiply by something to equal 1, we know that negative 4/9 we would have to multiply by the reciprocal, or negative 9/4, to make a 1. The exception to this rule for multiplicative inverses would be 0. It does not have one because nothing times 0 is going to get us back to 1. Also, if we were looking here at this number here, the 7/1, we could simplify that with division. We know 7 divided by 1 is just 7. So here we could do either or. So let's take this and try 2/5 times 5/2. Well, we all know from multiplicative inverses, that this is going to give us 1. I'm multiplying by a number by its reciprocal. But the question is why? So I have 2 over 5 times 5 over 2. And before we used our fraction strips, but now we're going to try it without having to do that. And so we're going to look at our fraction. Up on the numerators I have 2 and 5, so we're going to multiply those. And 2 times 5 is 10. And now on our denominator I have 5 times 2. Well, 5 times 2 is 10. So now we're here with our fraction, and I have 10 over 10. Well, we know we can simplify our fractions by doing division, and we know 10 divided by 10 is 1. So because these two fractions are reciprocals, they make 1 because they are multiplicative inverses. We could use this with our students with different word problems. If they needed to, we could try different fraction strips. We could also tend to use this now when we're going to use division and showing that division is actually multiplying by a reciprocal. We could also use this because we talked about the fact that 10 over 10, group these together. So our 10 over 10 here, we said that's the same thing as 1. And we're actually going to come to use this now with our fractions and remember that when we're looking for common denominators, we can always try to remember that a numerator and denominator, if they're the same number over top of each other, will equal 1. And so this is where we would then lead into. Thank you.